Hello, this is my submission for the Managing Machine Learning Projects course. I'm going to talk about a rate recommendation model. So, the use case that I have is how do homeowners understand which is the best electricity rate based on their consumption and other factors. Utilities provide a lot of advertising materials about different rates, but to homeowners, this can be very confusing since they do not understand which rate is the best for their consumption. Looking at the opportunity itself, first of all, is there a problem? There is a problem because utility rates and their breakup are complicated. Customers simply choose the lowest rate without considering that there are multiple factors that impact cost. Customers also expect that the utility would guide them on which is the best rate and how to choose a rate. And if customers are satisfied with the rate, they would not leave the utility for another utility that promises lower rates. Can this problem be solved by machine learning? Looking at the facts that multiple factors are involved in the calculation, there's historical data analysis, there are a lot of observations to come to a recommendation, and there are multiple rate options available. It is a good candidate for machine learning since these uh, necessities are best solved by machine learning. Does someone care about solving this problem? Yes, there is a need to solve or to provide customers with a rate recommendation system since it would reduce customer churn if they are satisfied with their current rate or they switch to a rate that makes them happy. There would be less calls to the utility call centers by customers and trying to understand the rates or asking why their consumption is not reducing or how does their bill work. And right now there is little to no recommendation being provided to customers. So the target user with this project is residential users or consumers of electrical energy which is sourced from a utility. The problem statement is residential users find it difficult to understand which is the best electrical rate for their home. Machine learning can be used to provide predictions of the best rate for a customer. What are the outcomes to consider? Customers can save money by switching to a rate that is actually good for them. Customers will be happier to switch to a rate, and once they're on a good rate, stay with that rate and in turn stay with the utility. So less churn of customers. Time saved because customers do not have to analyze their bills and try to figure out the best rate through manual calculation. Positive feedback for the rate for the portal of the utility and in turn for the utility itself can sense customers are happier getting better rates. The outputs that we're looking at from a performance perspective are mean absolute error and adjusted R squared. The factors to be considered by the model would be rate, which is the cost of electricity, the average monthly consumption. Average is being taken to account for fluctuations in data, property size in square meters, and the average monthly temperature, again, average to account for fluctuations. This data can be sourced from an external weather service or API. A brief diagram of how the flow of data would work. User information and rates would be stored in the database. The portal or system would extract information, call the model, pass the factors. The model would just generate the projected cost based on these factors. The portal would then calculate the difference in savings between the current cost and the projected cost. Based on that, deduce the recommended rate. Is the cost increasing or decreasing? And finally, store the predictions for that user in a table that can be used whenever demands are made from the customer. From a data perspective, all the data would be labeled and stored within the utilities customer portal. So that's one advantage. The other advantage is that data cleaning would not be necessary since the mandatory fields and the data itself would be in the required format. Average consumption would be calculated outside the model to reduce on the model's load. A cold start problem, new customers who are switching or using a rate for the first time, since they do not have billing history, their average consumption on based on customers with similar property size would be used. Validation plan to determine the first one is to determine the most impactful factors using combinations. So using single factor regression, calculate mean absolute error adjusted R squared, set a baseline, then use two factor regression, compare the performance between the models. Similarly, try three factor and all four factors and change the baseline as needed. The model with the best baseline would be used. A second plan involves using interaction terms. It is possible that some of the factors are related to each other, such as consumption and temperature. Higher temperature can mean more consumption. So, an experiment would be to try using interaction terms in the model's predictions to see whether the performance improves or does not improve. Lastly, we come to system level architecture decisions. The first being that the model should run in the cloud. Since the data is in the cloud, customers need to access the recommendation model anywhere and anytime. And it is not, predictions would be generated from multiple users' data and not a single user. The model would be trained offline, ideally once a month, when the billing cycle of that utility is complete, because new bills would be new consumption. Training in real time can disrupt site performance, and a lot of data needs to be processed while training. Model predictions will be generated in batch, again because we have a lot of data. 3 out of 4 factors are static, and since updates are not expected in real time, it makes more sense to handle the predictions in batch. Now, what are the risks that can occur in production? Data drift, mainly due to data fluctuations in temperature. Climate change can impact how temperature usually is week by week. And because the model is being retrained only once a month, there is a possibility that the model is using uh, a defunct temperature value. Drift is a more viable risk. Property size may cease to have an impact on consumption. So this is a change in factor weight. And if rates with time of day are introduced, the model would be unable to recommend these rates because it does not consider time of day as a factor. So rates with a time of day usage charges would need to be a new feature for the model to consider.